Well, what did I miss on Wednesday? What did I miss? You guys have fun? Yeah. Oh yeah, cool. So you dissected a sawtooth wave into cosines, huh? Yeah, and it worked.
It worked out as advertised.
And did you build it out of? Did you build it in MATLAB?
Yes, we used the. I guess it's the Fourier series, right?
Yeah, that's what you've done is Fourier series. So, so what was the code that he wrote? Like, how did it kind of work? Does anybody remember? Explain how the code worked.
He did a for loop set up. I think it was an X matrix, and then kind of added a new.
Added on to it. Good.
Find any normal cosine wave, and then just use the for loop.
Pretty cool. Pretty nice, right? So it is my understanding then that you've succeeded in building a sawtooth out of cosines, right?
Correct.
That's all right. That's pretty good. Good. So let's kind of just start by dropping that formula on the board real quick, and then I want to kind of ask some questions about it, and then we'll work into some new material. Let me just pull up my notes here so I know where we are. So we built a sawtooth. Okay, so I think for today we're going to mostly look at, we're probably dancing around lecture 7 in the book, 7 or 8. That's kind of my guess is roughly where we are. Okay, so so we built the sawtooth, and the sawtooth was it like this? Okay, great. And the period was 2 pi. So it went from minus pi to pi, from minus 1 to 1, and that was your x of t. So the equation of that line was, what do we say? It was a rise of 2 over a run of 2 pi, so it was t over pi. Okay, good. And it goes on and on and on for like infinity. And you should have solved the integral that said that the nth harmonic, right, the amount that you have of the nth harmonic is equal to 1 over t, where in our case t is 2 pi, times the integral from minus pi to pi, times x of t, which is t over pi. And now here's the part that always gets people. I'm writing this just so that we have a lot of practice in kind of getting this straight. So what we said, the frequency omega naught, right? The natural, like sort of the default frequency of this circuit is what? Of this signal. How many rads per second is this signal? Right. What's the period? Period is 2 pi. So the frequency in hertz is 1 over 2 pi, which means the frequency in radians per second should be 2 pi f, 1 rad per second. You with me? Okay. So omega naught, the frequency. So what's a good way to do this? So let's write it as omega sub 1. Okay. So the frequency of the first harmonic is 1 rads per second for this problem. Okay. What's the frequency of the second harmonic? Omega equals 2 rads per second. Okay. And what's the frequency of the nth harmonic? Right. So in generic form, here's what we're going to do. You're right. If it's basically going to be 1 times n rads per second, because it's always just going to be n times whatever the actual thing was in the beginning. So here's what I want to do, just to write this in a bit more of a generic way. So we said the period was t. I'm not going to use numbers now, I just want to use variables for a second. So the period is t, the frequency is 1 over t, and the frequency in rads per second is 2 pi over t. That's the first harmonic. So in general, what's the frequency of the nth harmonic? Right. If this is the frequency of the first harmonic, the second harmonic is this times 2, the third harmonic is this times 3, and the nth harmonic is this times n. Good. So 2 pi n over t. So now it's nice it's in a variable, right? You don't have to, nothing sucks more than having to do the same calculation over and over and over again, right? So look, don't keep overthinking this, right? We just made a formula out of it. In general, as long as you know the frequency, it's e to the minus j times the frequency of the nth harmonic, where the frequency of the nth harmonic will always be, right, will always be 2 pi n over big T, or in this case our big T is, right, so in our case the big T is 2 pi, so they cancel, that's nice, but I'm just sort of putting it there to make the bigger point that you don't have to like overthink this, right, so then it's little t dt. We good? So that's the integral you solved on Wednesday? No? Yeah, it is. Oh, I don't. It's all good. It's all good. All good. So what'd you get? Does anybody remember? E to the j pi over 2. E. Have I written it correctly?
You put a J on the bottom.
Put a, oh, you did what? What kind of nonsense did John do? Oh, John, really? E to the minus j pi n over j pi n? I have to start. E to the minus j pi n over j pi n? And he left it like that? Because that's craptacular. Okay. It's not wrong. That number may very well be right. I just happen not to like the way it's written.
Negative on the top also.
And there's a negative on the top?
He sent it that way just to show us something in MATLAB.
Oh yeah. Okay. But okay. Before I go on, can we? Is that the right number? Can somebody else verify that that's? Because I don't want to like work with this and then have it not work, right? Okay. So, okay, whatever. So you solve the integral and you got that the amount of the nth harmonic you have is that. Okay.
There wasn't a negative sign in the exponent.
There wasn't a negative sign in the exponent?
No, I don't have it.
Okay, so we're no negative sign in the exponent.
But actually, that wouldn't matter anyway because it was pi, right?
Ooh. Nice. Would it matter anyway if there was a minus sign in the exponent? No, because as long as n's an integer, e to the positive pi n and e to the negative pi n get you to the same place.
Well,
right?
if we're dividing by j, then negative could matter if we're adding or subtracting.
Nah, but the numerator, I mean, no, it won't make a difference. It won't make a difference. Okay, so that's the first thing I want to do. So this is fine, but it's sort of like a hybrid. It's not rectangular form and it's not polar form, right? And that gives me fits. So and we got this minus sign dangling outside. Nah, like I don't like that either. So let me just start by writing it in a polar form, if for no other reason than just because I'm anal retentive and it's like nice to have things written properly, and I think it also helps us illustrate a better point. So a sub n equals. Okay, let's start with the minus. The minus is really like I'm multiplying that expression by minus 1. So can I write minus 1 as a complex number? Sure. In polar form.
E to the pi.
Right. What's the magnitude of minus 1? 1. E to the j, and now I need to know its phase angle. So here's 0 degrees gives me positive 1. Pi over 2 radians gives me j. Pi radians gives me negative 1. So it's e to the j pi. So basically that's a fancy way of saying negative 1. I think I left this in the book. Did anybody read in the book that there's some like theologian or philosopher or something that argued that this was proof that God exists? Did you read this? This is like a famous thing. What's that? No, it may have been, I can't remember. Basically, the rationale goes like this. E to the e to the j pi minus, so e to the j pi is negative 1. So plus 1 equals 0. So the rationale goes like this. You've got the 5 craziest numbers in the universe, right? You've got e, which is like the exponential rate of growth of any like natural system. You've got j, which is the square root of negative 1. You've got pi, which is the ratio of a circle's circumference to its radius. You add 1 to that and you get 0. Like, that's so arbitrary that that all just works together in like such a clean formula that that cannot have come from a random universe, right? Like, that is so weird that that fits together. That must have been designed, not... Anyway, that's the rationale. I just believe it if you want. Don't if you don't. I don't care. But that's like sort of part of the folklore of complex numbers, is that some guy in the 1600s tried to argue that that meant God exists. Okay. Anyway, so we've got our minus 1. Let's see. I've got a 1 over pi n. That's easy. How do I deal with my 1 over j? What is 1 over j? Is that the same as negative j? Okay. So what can I do with negative j? E to the j. I got 2 choices, right? So again, here's 0. I want to get down to here, right? That's my minus j, because that's plus j and that's minus j. So I got 2 choices. I can either do the backstroke to 3 pi over 2, or I can just go down to negative pi over 2. Right? It's the same thing. I happen to like minus pi over 2. It's just, I don't know, less stuff to write. So that is e to the minus j pi over 2. So that's my fancy way of saying 1 over j. And what am I left with now? We got the minus, we got the 1 over pi n, we got the 1 over j. So all we're left with is the e to the j pi n. How's my driving so far? Is good? Okay. So, let's put this together. So what's the magnitude of this complex number? Right. It's just, that's all that's the magnitude. And the phase is e to the j. What do we got? We got pi n plus pi minus pi over 2. So plus pi over 2.
Isn't that where if it wasn't negative, it would matter, because then there's j pi n cancel?
No, it wouldn't make a difference. If this was minus, it would still be, it would be minus pi over n. Sorry, it'd be minus pi n plus pi over 2. It would still give you the same. It would still give you the same thing. And let's see. Do I want to factor out a pi just because I can? Yeah, why not? Why don't I factor out a pi? That's just showboating. I mean, there's no real value to that. Okay, but the reason I did this is that now I have a very clean formula. Okay, I know what my magnitude is, which is 1 over pi n, and I know what my phase is, which is pi n plus a half. All right. So, why do we use complex numbers? Right? We needed one integral, got us both the magnitude and the phase. Isn't that cool? Right? If we weren't obliged to use complex numbers, but if we didn't, we would have had to do 2 separate integrals to get that information, to get the amplitude and the phase. Whereas here, we got it all in one go, which is really nice. Okay, that's half the trouble. Right? One formula got us both parts of that. Okay, did you plot? I'm sure you rebuilt the sawtooth, but did you plot a sub n, magnitude and phase? Yeah. You did everything. What's left? Okay. All right. So when you plot a sub n, presumably you got a plot that got smaller. Right? So each one gets a little smaller. So you got a plot that looks like that. And then you did the phase plot. How did the phase plot work out? Right. So when n is 1, you've got 3/2 pi, which is the same as minus pi over 2. And when n is 2, you get 2.5, which is 5/2, which is the same as, right, remember 5/2 is 2.5, right? So look, here's pi, 2 pi, 2.5 pi, which is the same as pi over 2. So minus pi over 2, pi over 2, minus pi over 2, pi over 2. And that shouldn't surprise us, right? It's not surprising to me that all of our phases are either pi over 2, which means, so remember, we're starting with a cosine, right? If we take our cosine and give it a shift of negative pi over 2, what does that give me? If it's cosine, if it's a cosine and I give it a shift of negative pi over 2, that means it's going to shift to the right by pi over 2. So that means that I'm going to get that kind of a cosine. Or if I give it a negative pi over 2, that was negative pi over 2. If I give it a shift of positive pi over 2, what's going to happen? It'll shift to the left by pi over 2, and that will give me something that lines up like that. But either way, they're all going to cross 0 at that same point, which kind of makes sense, right? If they didn't, it would be really hard to get the sawtooth that's lined up exactly the way it is. All right. We all in the same boat? Okay. So I don't need to plot all this since apparently you did all that in class. So let me tease Monday's recitation for you. Let's do the same problem. So this is all about intuition building. Okay, this is all about intuition building. We're going to do the same problem, but just a little bit differently. So let me show you this signal. Sawtooth. Guess what period I'm going to give it? Same period, 2 pi. So from here to here, 2 pi. But instead of centering it up at 0, now I'm not centering it up anymore. So let's see what number we should pick. How about we let that number be, let's see. Should I do some multiple of pi? Is that going to make it any easier? I think it might make it a little bit easier. Why don't we say this number is minus pi over 3. Okay, so if that's minus pi over 3, what does this number have to be? We know that from here to here has to be how many units? 2 pi. Okay, so 2 pi minus pi over 3. Right. 2 pi minus pi over 3. So that's the same as 6 pi over 3. So that's 5. So this number has to be 5 pi over 3. So can we agree that this is the same signal as before, just shifted over by a little bit? Are we okay with that? Okay. We're going to do the same problem. Okay, we're going to get the amplitude and the phase of the cosines, and we're going to think a little bit about whether or not we could have guessed the answer without doing any more work. Because if it's true that you can guess the answer without doing any more work, that means you've built intuition. That means that you understand how the system is put together. Right? You don't always want to be writing integrals every time you see a signal, right? You'd like to get to the point where you can just eyeball it and have some idea about what's going on in it. That becomes value, right? Any monkey can like program numbers into a computer and pull the lever and get it to tell you what the frequency content is. That doesn't make you an engineer, right? What makes you an engineer is you can just have some feeling for how this thing works, and that's what I'm trying to teach you. Okay, so in order to build that, we have to do it the hard way. And then once we do it the hard way, we'll step back and say, could we have guessed that that was going to be the answer? Like, shouldn't have that been obvious? So that's what we're trying to do. Okay, so my goal is to get a sub n for this function. So help me out. What am I doing here? What's the first thing I need if I want to derive a sub n for this sawtooth? I need a function for x of t, do I not? Okay, hook me up. What's my function? So, yeah, let's just start. Let's start by writing the equation for that stretch of line. Deal? Okay, so it's a line, which means I need a slope and a y-intercept. So what's my slope? Same slope as before, right? Shifting it left and right doesn't affect my slope at all. So we can safely say that x of t is going to equal t over pi plus something. Before it was plus 0, right? Because the 0 crossing was at 0, right? The y-intercept was 0. But now my y-intercept is some negative number. How can I figure out what the y-intercept is?
Y equals mx plus b.
Yeah.
Plug in minus pi over 3 for t, and then say that your x of t has to be equal to negative 1 at that point.
Right. So this is the poor man's way of doing it, okay? There's easy ways and there's hard ways. This is how I do it, okay, because it's easiest. You know that, okay, basically there's some unknown y-intercept, right? And we also know that this line, x of t equals t over pi plus b, has to fit, those 2 points have to lie on there, okay? This point has the x value of, this point has the pair of negative pi over 3, comma, what's the y value on that point? Negative 1. And this point has the xy pair of 5 pi over 3, comma, 1. Both of those points should satisfy that equation. Okay, so if I take either of those 2 points, sub in t and sub in x of t, then I'll be able to solve for b. And it doesn't matter which one I use. All right, so which one should we try? 5/3 pi? Okay, so let me work here on my scratch space. So if you want to do that, it should be 1 equals 5 pi over 3, that's my value of t, divided by pi plus b. See what I've done? I've just taken this equation and I've substituted in one of the points that I know. 5/3 pi is my value of t, and 1 is my value of x of t. Now the only thing left to solve for is b. So 5/3 pi divided by pi is 5/3. So therefore b has to equal 1 minus 5/3, which is negative 2/3. Does it make sense that we get a negative number? Does it make sense that our negative number is between 0 and negative 1? Good. You get a little sanity check. It has to be, right? Because we know this number is negative 1. So this number had to be a little bit less than negative 1. And it was. So that's good. What if I subbed in the other point? Should have gotten the same thing. If I subbed in the other point, I would have had negative 1 equals negative pi over 3 over pi plus b. Therefore, b would have equaled negative 1 plus pi over 3, which equals, wait for it.
You cancel out the pi.
Thank you. I want to figure that out eventually. Negative 2/3. Either way, you get the same answer. Okay. So long story short, the equation of our line is t over pi minus 2/3. Questions? Are we okay? If you're not okay, yell out at me. I'm not a mind reader. I'm trying to be, but I'm not. Okay. Let's write our integral. A sub n equals
1 over 2 pi.
1 over the period. Period's still 2 pi. Integral. What's my limits of integration? Right, I got to do one period. I can do any period I want, but because I've defined my line from negative pi over 3 to 5 pi over 3, I'm going to let that be my period. Otherwise, I'm going to create major headaches for myself. Minus pi over 3 to 5 pi over 3. So that's one period. X of t, which is t over pi minus 2/3 e to the minus j, 2 pi n over big T, where big T is 2 pi. So that's nice. That's just going to be n t dt. There it is, folks. There's your integral. What do you think? Two separate integrals. And guess what we know? Guess what we already know? We've already solved one of those integrals, right? Because is it not true that I can rewrite this as 1 over 2 pi integral minus pi over 3 to 5 pi over 3 t over pi e to the minus j n t dt. So that's one integral. Then what happens? Minus. I like minus. 1 over 2 pi. Integral over the same period. Minus 2/3.
Plus 2/3.
Well, we got it right. It's either minus and plus or minus. Turns out it doesn't matter. Okay, if you put the minus outside, then this becomes a plus. Let's stick with that. E to the minus jnt dt. Well, look at that first integral. Does that look familiar? You already solved that on Wednesday. Did you not? Right, what happened when you solved this? On Wednesday, when we did the sawtooth that was centered, you got this integral, right? The only thing that was different is you probably used different limits of integration. But do the limits of integration matter?
No.
Right. As long as it's over one period, it's gonna, we know it's going to give you the same thing. So whether or not you went from minus pi to pi, or 0 to 2 pi, or minus pi over 3 to 5 pi over 3, as long as you integrated it over one period, you're good to go. Okay? And here's an integral over one period. So spare yourself the drama. You don't have to reintegrate this thing. You know that if you integrate this left-hand thing, you're going to get 1 over pi n e to the j n plus a half times pi. That's pretty easy, is it not? Now we got to deal with the right half integral. Question so far on what I've done. I'm trying to judge the blank stares that I'm looking at. It's 10:30 in the morning. You can't argue that it's too early.
Argue whatever you want. Apparently we can argue God at this.
I know, it's pretty cool, right? We're only on the 5th lecture. So you guys will get a kick out of this. If this is too early for you, you should know what I was doing on Wednesday. Wednesday, I went to a meeting that went from 9 in the morning to 5 in the afternoon in Washington, D.C. So at 6 a.m., I was on a train. I got up at 5, on the train at 6, made it to Union Station by about 8:10, jumped on the metro, took the metro to Foggy Bottom, got out of the metro, walked a mile to the National Academy of Sciences building, got there at 8:50, got a bagel, meeting from 9 to 5, wash, rinse, repeat. Got home at 9:30 at night and just like laid on the floor. Like, I'm tired. Anyway, so I feel your pain. Okay, now that right-hand integral, that's not so bad, right? Because I don't think we even need parts to solve that, right? Let's work the right-hand integral over here. It's I'm going to just leave the minus sign dangling for a minute. So I've got 1 over 2 pi. I can pull the 2/3 out, right? Because that's just a multiplier. And now I've got the integral of e to the minus j n t. What's the integral of e to the minus j n t? Beautiful, right? It's 1 over minus jn e to the minus jnt from the limits minus pi over 3 to 5 pi over 3. I told you that wasn't going to be too bad. It's a little ugly. Okay, it's like a lot ugly. All right, so let's see what we got. Those 2's cancel. That's 1 over 3 pi. We can bring the jn out. So that's minus jn. Is that good? And let's see what we've got now. So now we've got e to the minus j 5 pi n over 3 minus e to the j pi n over 3. Bleh. Have I screwed up yet? That's a legitimate question. I screw these things up all the time. What are we going to do with this? Oh my God. Seriously, what are we going to do with this? Somebody help me.
What did you do with the minus sign over there?
What's that?
The minus sign over there.
Yeah, it's just a minus sign. It's minus whatever that integral turns out to be. Yes?
We could factor a j pi over 3 out of the exponents of both of those exponentials.
That would help a little bit. I want to factor something else out, but I have to remember exactly what the number is. Yeah, so this is, this is like one of those tricks that you need to see it done like 10 times before you ever have the intuition to do it yourself. So don't like get excited. I'm going to average these two exponents. So this is negative 5 pi over 3. This is pi over 3. Okay, I'm going to average those two numbers. So let's see. If I add them together, I get minus 4 pi over 3. And if I divide that by 2, I get negative 2 pi over 3. So watch what I'm going to do. I'm going to take this expression, and I'm going to factor out an e to the negative j 2 pi over 3. So I'm going to keep my minus j 3 pi n, and I'm going to factor out e to the minus j 2 pi n over 3. Which minus? This minus? I picked it. What I did is I averaged minus 5 pi n over 3 and positive pi n over 3. I just took their average. And that's the number that I want to factor out. You'll know why in a second. I mean, this is like pure mathematical crazy talk here. Okay. So if I factor this term out of this term, what's left in the parentheses? E to the minus. It's got to be a minus. Minus j 3 pi n over 3. Does that make sense? Because minus 2 pi n and minus 3 pi n give you e to the minus 5 pi n. Okay, so there's that. Minus, and what happens to the other term? It'll be e to the positive, no? It's positive j pi n, sorry, e to the positive j 3 pi n over 3. Because look, 3 pi n over 3 minus 2 pi n over 3 leaves you with 1 pi n over 3. Cha-chung! Now, why'd I do that? Oh, what was that? This is a cosine? Yes! That's the trick, okay? Again, we're not going to do this like every time. This isn't like a thing you're going to have to do on a test. This is, remember I said we're doing this the hard way to build the intuition so that you never have to do this again. So don't lose sleep over this. But it's good to see the steps spelled out. Yes?
I'm not sure because of the minus sign. I'm not sure if it's a cosine.
Okay, this minus sign, because you're not sure if it's a cosine? Yeah. Well, watch this. Watch this. If I pull out this minus sign, okay, if I pull out that minus sign, then I'll have e to the positive j 3 pi n over 3 minus e to the minus j 3 pi n over 3. I don't think it's a cosine, actually.
Can't they just cancel it?
No. They're not going to cancel. So first of all, I pulled out the minus sign, so that minus sign went away. Is that a cosine?
No.
It's not a cosine. It's a sine.
It's a sinusoid, right?
Yeah, because remember the rule. Sorry, I need more scratch paper. Right, sine of phi equals e to the j phi minus e to the minus j phi over 2j. Therefore, e to the j phi minus e to the minus j phi is going to equal 2j sine phi. And lo and behold, that's what we have. Okay, so this expression can be replaced with 2j sine 3 pi n over 3, which is just pi n. And what?
Divided by j.
Well, okay, when n equals 1, I've got sine of,
Pi, which is 0.
when n is 1, I've got sine of pi, which is 0. When n is 2, I've got sine of 2 pi, which is, when n is 3, I've got sine of 3 pi, which is, when n is 4, shall I keep going? For every value of n, for every integer n, what is sine of pi n? 0. So this whole right side integral went to 0. Have a nice day. You're welcome. Isn't that cool? It's okay. It's at least a little bit cool.
Sure, it doesn't matter how much you shift the wave. I mean, it's the same. I mean, regardless. I mean, the wave is the wave. You're going to rebuild it out of cosine.
Yes, and that's the point. Okay, I think we've made one small mistake with the left-hand side, but it's going to be a lot easier to fix now. Okay, so let me back off. So we agreed that this whole right-hand side came to nothing, right? Yes.
Why couldn't you have just, like when it was like 3 pi n over 3?
Yeah.
Cancel out the 3's and when you just get -1 minus -1.
Yeah, you probably could have done it that way too. Yeah. I may have done more work than I needed to. Okay, so this whole, it's just gone. Okay. I think I screwed up the bottom part. I don't think you're going to get exactly the same number. No, you're going to get a phase shift attached to that. Okay, we're going to need to resolve this integral, actually. Do you mind? Okay. Let's do it, and then we'll be done. And then I think we'll really have something intelligent to say. But it is pretty cool that we agreed that that right-hand integral, that yielded nothing. And that was kind of cool, right? That all just melted away.
Well, didn't that came by because you shifted it?
Yeah.
So therefore you're going to have the first one is going to look different than the previous one because it's not.
Right. They have to be at least a little bit different. Right. Okay, so let's just do that real quick. So it's, right now we're just, I've decided that I'm not 100% sure that that answer is correct, so we're just going to actually run that integral real quick. So it's 1 over 2 pi integral minus pi over 3 to 5 pi over 3 t over pi. So I'll pull the pi out. So it's t e to the minus jnt dt. So now we need integration by parts. So remember, if it's t e to the at, there was 1, 0, 1 over a, e to the at, 1 over a squared, e to the at. So my integral is going to be 1 over 2 pi pi times t over minus jn e to the minus jnt. So that's that term. Minus 1 over a squared. So 1 over minus jn squared e to the minus jnt on the limits from minus pi over 3 to 5 pi over 3. Woo! Did you put your big kid pants on today? Ah! Okay. All right. Well, let's make the most of this. So I've still got my 1 over 2 pi pi. 2 pi pi. Okay, so 5 pi over 3 over negative jn e to the minus j 5 pi n over 3 minus 1 over minus jn squared e to the minus j 5 pi n over 3 minus over negative jn minus love of God. E to the positive j pi n over 3 minus 1 over minus jn squared e to the j pi n over 3. Holy mackerel. Okay. Don't taunt me. Don't taunt me. I'll do it. Rats. What's the next? What's the next step?
I would say, I don't know if it'll.
Can't you do
So
that?
we have
You shoot the minus sign, make it all forward like terms.
Can we put it in one?
And then factor out maybe a 1 over jn. That's gonna really help.
What am I just lost my train of thought here. How do we clean this?
Hang on the bottom square. Let's just, let's get rid of j on the bottom square.
You want to get rid of this term?
Yeah.
Well, what's that going to do for me? Let's see. So j times j is negative 1. So minus j times minus j is also negative 1. So that's going to basically just get rid of the minus sign.
Get rid of the J too.
Yeah, it'll get rid of the j. But
we could factor pi over 3.
right, the pi over 3 will come out of some terms. Hold on, why am I blanking?
I think those two terms cancel out.
Which,
The negative j and squared terms, those cancel out.
This term and this term?
Yeah, because 5 pi over 3 and negative, and pi over 3 are...
Okay, let's talk about that. E to the... Let's leave that there to drain a little bit. Okay, so that, I think now we might be onto something. Okay, so e to the minus 5 pi over 3. So that's e to the minus pi. Minus pi is negative 3 pi over 3. Okay, so minus 5 pi over 3 is like this, right? So this is the same as 2 pi over 3, or minus 5 pi over 3 is the same thing. Okay? So, no, this is pi over 3. There we go. Because those have to add up to 6. So what you're telling me is that this term and this term are the same.
So they cancel out.
I'm with you, 100%. This term, so e to the minus j, 5 pi n over 3, is that number, which is the same as that number. So you've got minus some expression plus the same expression. Okay, so I'm with you. So you've just made my life simpler. I thank you. So we just dumped, this term goes to 0, and this term goes, so those terms have canceled. So now we're just left with this. Those minus signs cancel. That makes a plus. Okay, I'm liking this a little better. I'm going to bring the minus jn, we'll factor out front. So 1 over minus jn.
Use the same logic to turn negative j 5 pi n over 3 to just j pi n over 3. Then combine those two terms.
So you're telling me that e to the minus j pi 5 pi n over 3 is really the same as that expression? I'm totally with you. Okay, so that gives me e to the j pi n over 3. Oh, and now I can combine those? So 5 pi over 3 plus pi over 3 is 6 pi over 3, which is 2 pi. Oh, snap. Look at that. Okay, so I've got 1 over minus jn, 2 pi, pi, times 2 pi e to the j pi n over 3. So the 2 pi's cancel. All right, and now I'm left with 1 over minus j n pi e to the j pi n over 3. Okay, so close. I just need to polish this up just a little bit more. It was j pi n, 2 pi times pi, and that 2 pi canceled that 2 pi, or you're still left with a pi term. What am I going to do with that minus j in the denominator? Right. Right, minus 1 over minus j is the same as j, and j is the same as e to the j pi over 2. So finally I can rewrite this as 1 over pi n e to the j pi over 2 plus n pi over 3. And for those of us who really want to be anal retentive, just like I did before, I'll bring out the pi. Okay, I'm back now. All right. So, what?
When you had first canceled out the j pi pi n over 3 on both sides, the one that was left on the left side when you first added them together,
yeah.
what happened to that when it was negative j pi pi n over 3 plus the pi over 3 equals j pi n over 3?
If we're thinking about the same thing, the complex exponentials were the same value. E to the minus 5 pi over 3 is the same as e to the pi over 3.
Yeah, no, I get that part, but after that, when you were left with both left sides.
You just add them together. Okay, can I show you after class? Because I've got like 4 minutes left and I want to make this point. Okay, so in summary, before we did the shift, we had a sub n was 1 over pi n e to the j, a half plus, what was it? A half plus n times pi. Are you with me? Okay. After the shift, we had a sub n equals 1 over pi n e to the j. Look at that. 1 half plus n over 3 pi. Yes?
If our phase shift would have been positive pi over 3, would it be minus n over 3?
What do you think? So we just did a whole lot of math. I dried up 2 markers doing this. Okay? Did I need to sacrifice 2 markers for this nonsense? Look, okay. First, and forget about the phase for a minute. What do you notice about the magnitudes of these 2 functions? Why? It's the same wave, okay? Right? When we find the first harmonic, okay, what we're saying is how much omega equals 1 is in this signal. Okay, and we solved it and we got an answer. Does the answer to that question, how much omega equals 1 is in that signal, does that change if we shift the signal a little bit? No! If you shift the signal to the right or to the left, you have exactly the same amount of that frequency, right? You have the same amplitude because you didn't change anything. All you did was shift it a little bit or a lot. Who cares? But the amount you have of the first harmonic is the same. and the amount you have of the second harmonic is the same. Okay? That's why we're building intuition. Okay? Shifting it doesn't change the amount of each cosine that you have. What does it change? The phase. Okay? What does change is the phase, how it lines up. So, what I want you to get from this lesson is this. The magnitude tells you how much of the stuff you have. The phase angle tells you where it lines up, right? How much each one of those cosines gets shifted to the right or to the left in order to make your signal add up. Okay? So if you shift your signal to the right or to the left, it does not affect your magnitude because you haven't changed the amount. All it does is it changes the phase a little bit. Let me ask you this question, okay? You don't even have to answer it, but just think about it on your way out of here. Suppose instead of that sawtooth, I gave you that sawtooth. Same period, 2 pi. And we went through all the trouble of getting its Fourier transform. What do you think the magnitude would look like? Same magnitude. Why? Have you changed the frequency content of it? No, you just knocked it up a little bit. But you didn't stretch it, right? You didn't change like any of the frequency content. All you did was move it up. So there's no change in the amplitude.
But the moving it up will add to, does it add to?
Does it add to the phase?
Right.
If all you do is move it up, does it change the phase? No. It just adds a constant. It doesn't shift it. So if there's no change in the shape of the signal, there's no change in the magnitude. If there's no shift in the signal, there's no change in the phase. Okay? That's a powerful intuitive lesson. Yes?
Our problem, the way we shift it to the right, correct?
Yep.
So we should have like a negative phase in here?
No. We shifted it to the left. Well, okay, when you have a periodic signal, shifting it to the right and shifting it to the left are sort of the same thing. You could do the same thing by shifting it to the right a little bit or to the left a lot. It's periodic, so don't wrap your head around it too much. On Monday, we'll start by plotting this, okay, and prove that we get the same thing. Okay? Also on Monday, we're going to talk about your computer assignment, which is you should be reading. I've posted your first computer assignment. Yeah, you should read it. On Monday, I'll talk about a little bit about what I expect. Okay? Thank you.